Dear students, in this video I am going to explain the Graham's law of diffusion. This is very important law in chemistry. The first point is the rate of diffusion of given mass of gas is inversely proportional to the square root of its density. It may be mathematically written as R is directly proportional to 1 by root D, where R equal to rate of diffusion, D is equal to density of the gas. The rate of diffusion for two gases is given by R1 by R2 is equal to square root of D2 by D1. There is another expression for Graham's law of diffusion. The rate of diffusion of a gas is inversely proportional to the square root of its molar mass. So R is directly proportional to 1 by root capital M. Or it can be written as R1 by R2 is equal to square root of M2 by M1 for two gases. Another definition for Graham's law of diffusion is the rate of diffusion of a gas is inversely proportional to the square root of its vapor density. So R is directly proportional to 1 by root Vd. Vd means vapor density. For any two gases, R1 by R2 is equal to square root of Vd2 by Vd1. This is the expression for Graham's law. And if T1 and T2 are the times of diffusion for identical volume of two different gases, their rates of diffusion will given by R1 is equal to V1 by T1 and R2 is equal to V by T2 for two different gases. If we combine these two, we get R1 by R2 is equal to T2 by T1. From the above equations, the rates of diffusion of two gases is given by R1 by R2 is equal to square root of D2 by D1, and that is equal to square root of M2 by M1, and that is equal to square root of Vd2 by Vd1, and that is equal to square root of T2 by T1. So we can use the different expressions according to the problems. Now I am going to give you the applications of diffusion. There is very important applications of Graham's law. Number one is in the separation of uranium isotopes. Uranium-235 and uranium-238 are separated based on Graham's law. The second use of diffusion is molar mass of an unknown gas is determined by comparing its rate of diffusion with that of the gas of known molecular mass. And third most important application of Graham's law of diffusion is Anneal's alarm, which is used to detect explosive marsh gas, methane. Marsh gas is also called methane in coal mines, works on the principle of diffusion. Dear students, here I have noted some of the important problems on the Graham's law. Pause the video and note it down into your notes if you want. Observe the formulas which were used to solve the problems. I will explain the problems in separate video. Now the first problem is ammonia and chlorine gases. Two gases are given. These two gases, R2 value of chlorine, we have to find rate of diffusion for R2 value. See, so here I am using R1 by R2 is equal to square root of M2 by M1. So R2 is equal to 0.245 liter per minute. So here at this step you have to squaring on both sides, then you will get the answer. Otherwise if you want to find root value, use this logarithm. So here log 17, 71, subtract these two values and don't forget to divide with 2 and find the anti-logarithm. Next problem, here carbon dioxide and another unknown gas is given. So you have to find the vapor density of unknown gas. So I use the formula R1 by R2 is equal to square root of Vd2 by Vd1. Then I will find 25.19 is the vapor density of unknown gas. Here squaring on both sides, you will get this one. Okay, next. Here I noted down the two important problems. In the third problem, methane and unknown gas. So M2 value find for molar mass of unknown gas is found in this problem. And last problem, fourth problem, is very important one. HCl and ammonia are two different gases are sent in 100 meters tube. Then you have to find and which distance from A these two gases are combined. So then X value, I find X value, that is equal to 40.56 meters from A. So this is the end of this video. So I will explain in separate video how to solve these problems. Till then, have a nice day. Thank you for watching, and don't forget to subscribe my channel. Thank you.